Hello everybody, today we are talking about Chapter 10, which is Introduction to Simple Experiments. And we have gotten through this far in the semester, and this is the first time we're actually talking about a true experiment. So what's an experiment? Well, an experiment allows researchers to see how things turn out when one and only one thing is changed. We've talked about the terms independent and dependent variable before in this class. So the independent variable, or IV, is the variable that you manipulate as the researcher, and the dependent variable, or the DV, is the variable that you measure, or we call our outcome variable. So our independent variable might be, we manipulate a kind of new drug, a drug treatment, and we are measuring levels of anxiety, let's say. The independent variable that you manipulate is the actual variable that you are manipulating, and the conditions are the levels or the groups of that variable. So if we manipulate a type of drug on anxiety, then the levels would be maybe the new drug compared to a placebo, or compared to the old drug. So the conditions are the levels or the groups of the independent variable, and the dependent variable is what you are measuring. The three musts of an experiment, and we're going to go through these three in greater detail in a second. Number one is you must have manipulation. You must experimentally manipulate the levels of your independent variable. That's a key for an experiment. You must have experimental control, meaning that you hold all sorts of extraneous variables constant and treat everybody equally. And you also must have random assignment, that every person in the sample has an equal chance of being assigned to any condition. So let's first go through manipulation, meaning that you must manipulate your independent variable and observe the effects on the dependent variable. So if I was doing an experiment on watching violent TV and how that affects aggression in children, I would have my sample. Let's say I have 100 children that are in my study, and I would manipulate the independent variable, which in this case is violent TV, or type of TV that a child watches, and I would have half of the children watch 3 hours of Cops, and half of the children watch 3 hours of Barney as our non-violent TV. So I've manipulated whether they're watching violent TV or not. And then I'm measuring, maybe after they watch those 3 hours of television, I put them all in a room with a one-way mirror, and I'm counting the number of aggressive acts that I see during the time they play in that room. So if you have manipulation, that's the first must of an experiment. The second is experimental control, meaning that you have to have a lot of control as a researcher, that you hold constant any extraneous factors that might affect the outcome of the study. So I am sure to have everybody treated equally and be sure that everything is the same, basically, between the groups, except for one group, in the case of this study, is watching Cops, and one group is watching Barney. So what do I mean by that? Well, I would have them watch TV or watch the TV in a similar room at the same time of day, that they both watch 3 hours of that TV program, that the room is painted the same color. I don't know, that might have an effect. Everything is the same. I give each group the exact same instructions. I probably should have the same experimenter giving those instructions. Everything is the same. The toys that they get to play with, right, should be the same for both groups. The room that I'm observing them in is the same. Everything should be the same, except that one group watched 3 hours of Cops and one group watched 3 hours of Barney. And the only difference, then if I see a difference in aggression, I can say, ooh, yeah, that must be due to the fact that one of them watched a violent TV and one of the other group didn't, right? You could imagine if I didn't hold the groups constant on time of day, meaning let's say I had the Barney group come in the morning at 9 o'clock. They watched till noon, and then I did the observation. And then I had the COPS group come in at 3 o'clock, watch till 6 o'clock, and then I did the observation after that. And if I saw a difference, if I saw that the children who watched COPS were more aggressive than the ones who watched Barney, would I be able to conclude that it's because one watched COPS and one watched Barney, or would it be perhaps because they were observed at different times of day? And if you have spent any time with young children usually are much better behaved in the early part of the day, and by the end of the day when they're tired, they get cranky and more grumpy and perhaps more aggressive, and so I would have a confound there with time of day. So my goal is to keep both groups exactly the same except for the level of the independent variable. But of course it is difficult to keep all variables constant. It's hard to keep particularly what we call participant variance or participant variables the same, because ideally you would want um, the exact same people in the COPS group and the Barney group. The only way you could have the exact same people would be if you studied only identical twins, right? And had one in one group and one in the other group. At least they would have the same genes, but still they would have differences in terms of maybe their friends, or one of them watches more TV than the others. And it's very difficult to get groups of identical twins to be in research studies. So we have a lot of participant variance if you think about IQ and motivation and how were they parented, and what are their friends like, all sorts of things, previous TV exposure. These are all variables that we would like to be the same between our participants in both groups, but it's really hard to guarantee that. And so what we do is we use randomization. That's the third must of an experiment, is that we try to control all of these participant variables by randomly assigning participants to groups. So in this case, we've got two groups. We've got our COPS group and our Barney group. And if I have 100 participants who have decided to be part of the study, I would randomly assign them. Put all 100 names in a hat and pick out 50 names. They're in the COPS group, and the other 50 names are in the Barney group. And in that way, my goal is that I randomly kind of control all the participant variance, meaning by doing this in a random way, I should have just as many people with a high IQ in one group as a high IQ in the other group, and just as many people with lower IQs in one group and lower IQs in the other group, and just as many people who watch lots of TV in the COPS group as the Barney group, and just as many people who watch very little TV in the COPS group and the Barney group. And I'm trying to randomly kind of equal out all these participant variables, right? This would be different if I didn't randomly assign, if I said, hey, welcome to my study, to these 100 participants, and said, I would like you to choose. You're going to watch 3 hours of COPS or 3 hours of Barney, and I'd like you to choose what you'd like to do. That would not be random assignment. And then again, if we saw a difference in aggressive acts, let's say we saw that children who watched 3 hours of COPS were more aggressive than those who watched 3 hours of Barney, could we really say that it was watching the TV that caused the aggression? No, because if they've chosen what group they're in, perhaps the more aggressive children would choose to watch COPS, and the less aggressive children would choose to watch Barney. And so we couldn't make a conclusion or a cause and effect statement, which is what we're trying to do with an experiment. So random assignment to groups is extremely important. Please note that even though we have randomly assigned to groups, we can't guarantee that the groups are equal on things like IQ and parenting style and TV experience. It's the best we can do is to randomly assign and kind of hope that this randomization equals out the groups on all of these different variables, but it's not a guarantee. It's just like when we said, if you flip a coin 10 times, you should get about 5 heads and about 5 tails, but it's possible to get 10 heads in a row or 10 tails in a row. So same thing, we could have tried to do this random assignment, but the goal is to try to help with keeping and controlling the effects of the participant variables, but it's not a guarantee. It's just the best way we have. Now, we've talked about random sampling and random assignment. Those are two different terms, and people often get them confused. So random sampling, that was from our sampling chapter. This is how you pull a sample from the population, right? Are we going to do simple random sampling or stratified random sampling or cluster sampling? And this is when every person in the population has an equal chance of being in your sample. Once you have your sample, so once you have the 100 people or so who are going to be in your study, then we do random assignment. And this is how you assign participants to groups. When you have random assignment and random sampling, the idea of random helps establish validity. So random sampling, so randomly sampling from the population, that allows your sample to generalize to the larger population. And so we say that random sampling helps with external validity. Whereas random assignment, that is putting people into the different groups in a random way, equates your conditions before you apply your manipulations, and that has to do with internal validity, being able to say something about cause and effect. You must have random assignment for something to be an experiment. You must have random assignment to be able to say anything about cause and effect or to have internal validity. But you don't always need random sampling. You could have a convenient sample. Maybe I'm using children in this Cops and Barney study in my children's school because, hey, that's convenient to me. I can know a lot of the parents and I can get them to participate pretty easily. So I use a convenient sample. Well, that limits my generalizability. Who can I generalize this study results to? Well, it would probably be to people who are similar in their demographic characteristics to the people who are at my children's school. However, even with a convenient sample, I would still need to do random assignment, and I could still have internal validity. I could still say, yes, watching Cops caused children to be more aggressive than those who watched Barney. I had a lot of internal validity. I can say something about cause and effect, but I have limited external validity. There's only so far that I can generalize these results. So why experiments support causal claims? Well, 3 things are happening. Let me just check here. We're going to talk about them in a second. Experiments establish covariance, temporal precedence, and internal validity. These are 3 things that we want to be sure our experiment does, and a well-designed experiment will do this. Covariance is just the idea that you have a different level of the dependent variable depending on the level of the independent variable. So I say, oh, I see covariance. I see that when children watch Cops, they have higher levels of aggression than those who watch Barney. Independent variables answer the question compared to what? The idea that we must have a comparison group, that it's not good enough to just look at one group, have one group of children watch Cops, see how aggressive they are and make some conclusion. We compare because we have different levels of the independent variable. And we compare our experimental group to a control group. That would be someone who gets no treatment. Or we could have different treatment groups. And let's think about medication. You could do this for all different types of independent variables, but we could do a group that gets a medication compared to a group that gets no medication and look at, let's say, their symptoms of anxiety. We could compare one or more treatments. So maybe we try my new anxiety medication compared to an already established anxiety medication, something like Xanax, and we compare anxiety symptoms between the two treatments. Or we could also have a placebo group. So we could have a new anxiety medication and then something that looks like an anxiety medication, looks like a pill. People take it the same way, but it has no active ingredient in it. And so we could look at a placebo group compared to a control group on levels of anxiety. But either way, you would want to see that you have a difference in the dependent variable depending on levels of the independent variable. Temporal precedence, this is important. This is the idea that the cause precedes the effect. This is because we put people into groups, then we randomly assign them to, groups, then we give them their treatment or their control group, whatever it is, and then we measure the dependent variables. So we know that the independent variable came before the dependent variable change. This is different than correlational studies, which we've talked about, where you're just measuring two things that have naturally occurred at some point in time, but you don't know which came first. So by first doing the manipulation and then doing the measurement, you know that the cause preceded the effect. We want to establish internal validity, meaning that we can say that the independent variable causes an effect in the dependent variable and that we don't have any confounds. And a confound is something that confuses your results. And we're going to talk about design confounds and selection confounds. A design confound is when a second variable systematically varies along with the independent variable and provides an alternate explanation for the results. A second variable in your design that is different between the groups. And this could be, like I talked about before, if we do one test, the COPS group at 3 o'clock in the afternoon and the Barney group at 9 o'clock in the morning. Well, we have a confound there because we've got a difference in the design between the two groups, and we don't know if we see a difference in aggression, if it's due to one watching Cops or one watching Barney, or that they were tested at different times, right? If we tested them at the same time, but one of the groups was tested in a room painted blue and one of the groups was tested in a room painted red, again, we have a design confound because is aggression caused by the independent variable or due to the paint color on the walls? The problem with a design confound is when we have what we call systematic variability, that another variable is systematically different between the groups, meaning that everyone in the COPS group saw the show at 3 o'clock in the afternoon and everyone in the Barney group watched the show at 9 in the morning. That would be systematic variability. What's not really a problem is unsystematic variability, and this is when there are design variables that randomly are different between the groups. So imagine instead of testing everybody together, we tested these 100 kids individually, and so they each watched 3 hours of TV on their own, and then we looked at aggressive acts in some way after that individually. And so for those 100 children, we had some at 9 in the morning and some starting at 3 in the afternoon, but it wasn't systematically different. We kind of had equal numbers of kids watching Cops or Barney at 9 in the morning and equal numbers of kids watching Cops or Barney at 3 in the afternoon. In that case, we have unsystematic variance and it's not a problem. The problem is when we have a systematic difference between the groups that's something other than the independent variable. And selection confound is another problem. This is when the participants in one level of the independent variable are systematically different than participants in the other level. For instance, if I said, hi, I have 100 people here who volunteered to be in my research study, and I have to divide them into who's going to watch Cops and who's going to watch Barney. And so I'm just going to do this kind of easy, and I'm going to have all the girls watch Cops and all the boys are going to watch Barney. That's a problem, because if I see a difference in aggression after the study, again, do I think that can I say for sure it's due to the TV they watched? Or it could be a gender difference. So I need the groups to be the same, and we avoid any kind of selection effects with random assignment, that we randomly assign people to groups. And by doing that, I should get an equal number of boys and girls in both groups. Like I said, equal number of higher and lower IQ people in each group, higher number of motivated versus less motivated people in each group. But again, random assignment is not a guarantee. It helps, but it's not a guarantee. And so we can make sure that our groups are equal in terms of participants on a few characteristics by doing what we call matching. So if I thought that in this case we're looking at GPA, that I think GPA is really important in, let's say I'm doing a memory study. I have a group 1 who's getting a memory intervention. I'm going to teach them a new memory skill, and this group is not going to get that memory skill, and then we'll test them on memory. And I think GPA is going to be really important, that the groups are equal on GPA to start with. So if I have 100 people who have volunteered to be in my study, I could give them all an IQ test and then take the 2 highest IQs in the whole 100 people in my sample. And then once I know the 2 highest IQs, I randomly assign one to group 1 and one to group 2. Then I take the next 2 highest, GPAs, that's what we're looking at, the people with the next 2 highest GPAs, and then again, randomly assign one to group 1 and one to group 2. And then so on and so on. In that case, I now know that my groups are equal on IQ. And I've randomly assigned them into the other groups. And so hopefully for all the other participant variables that could be important, again, motivation, parenting, I don't know, all sorts of neurotransmitters, we could think about it in all different ways. We have randomly assign them to groups and hopefully even them out in all the other variables, but we're sure to match them on something that we think might be important. Types of experiments, we're going to talk about independent versus within groups design, post-test only, pre-test, post-test. So in independent groups or a between subjects design is when you have different participants at different levels of the independent variable. Okay, we have different people at in different groups. Kind of like this design here where we've got one group that gets the memory test or the memory skill, and those are different than the people who are not taught the memory skill. Within groups design is where each participant is presented with all levels of the independent variable. And so they actually are tested multiple times at these different levels. So a post-test only design here, we randomly assign our participants into 2 groups. One group gets the independent variable, one group gets the second level or the control of the independent variable, and then we measure both groups on the dependent variable and compare them. So in this case, we're randomly assigning people, some to take laptop notes, some to take written notes, and then we give them both a test on how much they comprehend from a lecture. And so we're comparing this group of people who took the laptop notes and this group of people who took the longhand notes on their comprehension. These are different people in both groups, but because we randomly assign them, we kind of assume that they're equal on all the things that would be important, probably on IQ and GPA and motivation and all of that. And if we see a difference, maybe people who take written longhand notes did better on the comprehension test than those who took laptop notes, we could say that type of notes causes a change in comprehension test scores. We could do a pre-test, post-test design where we take people and we could randomly assign them to two different groups. We do a verbal GRE score, okay, for both groups. Then we give one group a mindfulness class that we think is going to help them with their verbal GRE score, and one group gets a nutrition class. This would be like a kind of a placebo. It's a different kind of class, but we don't think it will have an effect. And then we test them again on verbal GRE. So now we could compare within a group the people who took the mindfulness class before and after, and then the people who took the nutrition class before and after. This is like a pre-test, post-test design. And so that gives you the ability to look at, instead of just assuming the groups were equal, let's say before on verbal IQ, you actually can look and see, oh yes, look, they both got about a similar score on verbal GRE score. Then we did the treatment, and then if we see that verbal GRE score goes up for those who took the mindfulness class compared to those who didn't, we have again reason to say that something about a mindfulness class causes an increase in verbal GRE scores. So advantages of within subjects designs is that participants serve as their own control. So like this, we can compare each person's score before and after the mindfulness class and before and after the nutrition class. And so we say that each person is their own control, and there's no better control than your own self, right? Everything about the person is the same. They're the exact same person before and after. The only difference is the mindfulness class. And so if GRE scores went up after compared to before, then we can say we feel pretty confident that it was the mindfulness class because the person is the same person. And we say these designs give researchers more power to notice differences between groups. You have less variability, you have less participant variability, and it's easier to see the effect that you're looking for. Also, you can have fewer participants because each person serves as their own control. You don't need to necessarily get an entirely new control group. Problems with within subjects designs is that you can see what we call practice effects, that a participant gets better at a task from practice. So when you do the GRE first, before the mindfulness class, and then after, well, some people will do better the second time because they've seen the test before. They've learned a little bit about the test. They've practiced it. And so even if the mindfulness class is not helpful, you will probably see an increase in verbal GRE scores just due to practice. Or you could see the opposite, which is people get worse due to fatigue. Imagine I'm doing some kind of energy supplement study, and so I'm going to have you run a mile and then give you the new energy supplement and have you run a mile after the energy supplement. Well, by the second mile, people are probably going to do worse just because they're exhausted. Okay. And we also have the idea of carryover effects, that sometimes what you teach someone will carry over from one condition to the next. For instance, if I think mindfulness is going to work, but I'm also kind of interested in meditation, and I could do this multiple times. I could do a verbal GRE, then a mindfulness class, then test verbal GRE again, and then on the same people do a meditation, and then verbal GRE again. Well, can I really take away what I've taught them about mindfulness by the time I get to the last condition? No, that mindfulness class will stay with them. It will carry over and contaminate the next condition, meaning the next condition would not just be the effect of meditation, but it would be mindfulness plus meditation. So how do we deal with that? We do this by what we call counterbalancing or switching the order around. So in this experiment, we've got how does chocolate taste the best if you're eating chocolate alone or with someone in the room? So we have someone taste chocolate alone, rate the chocolate, then taste chocolate again with someone in the room, a confederate, and then rate the chocolate. Well, this is a potential practice effect or a carryover effect that maybe the first time you taste chocolate, it just tastes better because it's so delicious. And then the second time you taste it, because you've already had some a few minutes earlier, it's just not as good. And so to kind of counterbalance these order effects, we have some groups, some people taste chocolate alone, rate the chocolate, then taste it with someone else in the room and rate it. And then we also have people who first taste the chocolate with someone in the room, rate it, and then alone, and then rate it. And by doing this, we call counterbalancing. You equal out any of these order effects because they will kind of cancel each other out. So which design is better? Really, the situation in your study determines which design is better. In some situations, it's really problematic to use a pre-test, post-test design, that the practice effects are too great, people get too exhausted, you can't figure out how to not have a carryover effect, and so in that case, you just wouldn't use it. You would use a between subjects, a two-group design. In other situations, it does make more sense. So you really have to think about the study and then decide if you're going to do a within or between subjects. There's really not a right or a wrong way. We already talked about counterbalancing. You don't have to worry about full versus partial. Don't worry about that for the test. And then interrogating causal claims with the 4 validities for an experiment. It's just like we've done before. And we'll go through these ideas of construct, external, statistical, and internal. Construct validity, again, how well were the constructs measured? Do you like how they measured the dependent variable in our study of aggression? How did they measure aggression? Do you think that was a good way to measure aggression? How did they measure the independent variable and how was it manipulated? Did they do a manipulation check, meaning they actually checked to see that there was the true manipulation they wanted? And you can also do this with a pilot study. You can read about these in your textbook. External validity, who can you generalize the study to? What other people, who are the other people, other situations? Again, look at who are the participants, to who can you generalize your claim. Statistical validity, did they do the right statistic? Is it statistically significant? How large is the effect? Here's a Cohen's guide for effect size. And so when they present, very often statistically, they'll present Cohen's d, which is a measure of effect size. If you get a Cohen's d that you're reading about, that's a small effect. 0.5, that's a medium effect. 0.8, that's a large effect. And so this is how large of an effect did the independent variable have on the dependent variable. And internal validity, you're going to be reading the study and looking, were there any design confounds? Was random assignment used? Was there counterbalancing? Are there any questions about the conclusion they draw about cause and effect? Or is it, or do you feel pretty comfortable with their causal claim? If there was a design confound, that would be an issue. And so you'd want to say, I don't know that I would believe this causal claim. I feel like there is potentially another explanation. Were the two groups similar, using random assignment or not? Or how was counterbalancing used if needed? All right, thank you very much, everybody.